Welcome to the fifth session of our Virtual Production 201 series. In this session, we will cover what you need to know about lighting on an LED volume, some common misconceptions about LED lighting, and how you can maximize the realism and immersion of your scenes when you're working with in-camera VFX on an LED volume. I am your host, Jace Lindgren, a solutions engineer at Perforce Software. I specialize in version control and help media and entertainment studios optimize their workflows and pipeline automations. The goal of today's panel is to give anyone interested in or beginning to work with virtual production an introduction to setting up quality lighting on your LED volume for professional productions so that you can set yourself up for success. And to do that, I am joined by three expert panelists. First, we have Chuck Edwards. Chuck is a VP of LED Innovation at NBCUniversal, where he leads development of Cineo lighting products. He's also a key contributor to the virtual production stage on the lot at Universal City. For the past 10 years, he's focused exclusively on color LED lighting technologies for film and television. Chuck has 30 years experience in R&D of solid-state lighting, electronic materials, and color imaging, and is inventor on over 50 patents. Tim Kang is an LA and New York City-based cinematographer, the principal engineer of imaging applications at Aperture, and worked as the principal engineer for color and imaging at Quasar Science for almost 6 years. He also co-founded and currently chairs the Lighting Committee for the American Society of Cinematographers Motion Imaging Technology Council. Jeremy Hochman is co-founder of Megapixel VR, a pioneer in visual technology, including processing, screen analytics, and display tech. He's actively involved in SMPTE's Rapid Industry Solutions Group, a member of the TV Academy, and has been doing virtual production for 20 years, since before it was called virtual production. Thank you all three for being here.
Thank you. It's an honor to be here.
Yeah, it's really great.
Thanks so much. To start this discussion, let's make sure we cover some basics of what we're talking about today, as well as some terms. And the first of those that comes up is the title of this panel has to do with lighting for the Outer Frustum. So what is a frustum? What are we talking about here?
Sure, yeah. Well, the frustum is basically what the camera actually sees of a scene. So it's that rectangle or square or whatever your frame actually is. What do you consider the frame that the camera sees is what I would call the frustum. And when we're talking about the inner frustum, we're talking about the camera seeing within that box. And then the outer frustum would be what you look at outside that box on set.
Yeah, when I think of the outer frustum, I think of the environment that's implied by the image on the wall. So if it's a cafe on a street, what's in the frustum might be a table, a chair, a wall, maybe some background buildings. But what the outer frustum implies is likely that there's sunlight, there's shadow, there's other surfaces, other light sources potentially in that scene. And when you're lighting for the outer frustum, you're trying to reproduce the lighting of that environment. You're trying to reproduce the environment that is being depicted inside the frustum, inside the lens of the camera.
Absolutely. And it's all about establishing that realism. Same thing could go for, stained glass windows. You could have a very wide establishing shot and then something filmed in virtual production that is, a bit more close up. And if you have that cast light coming through and hitting somebody's face, the shoulder, that they're in that environment without having to now show that entire environment the whole time.
Cinematographers and light technicians specifically call this motivated light.
That's a great point, Tim. When you say the motivation for the lighting, that's a noun. It means a specific light source to a cinematographer that represents what's happening in the scene. And it's not just an adjective. It's actually a real concept for a cinematographer like yourself.
And so just to clarify a little further, when we talk about lighting for the outer frustum, I think some people might think, when I say the frustum, it's that rectangle that's on the wall, that's where my camera is looking, and then outside of that is the rest of the screen. But when we're talking about lighting for the outer frustum, we mean everything that's outside of that back plate, whether they're physical lights off of the LED wall or they're lights coming from the LED wall. Is that correct?
This is still normal production, but just with a new technique of, making more interactive backgrounds, and then we're lighting the lighting techniques still apply.
Even though there's this massive drum of LED and potentially a ceiling, it's providing what would have been green screen before. It's providing what would have been a natural location, if it was shot outside, but it doesn't remove the fact that you need grips and a lighting package to properly light what is in the scene to look realistic and to give the effect that you want. Because the LED panels, if you take a large television and put it off camera, it's not going to illuminate people the way that an environment will. And that's basically what we're talking about, is we've set up like a 100-foot wide TV. So it's great to take a picture of it and it looks like the background is real, but nothing in the foreground is going to be lit properly.
Great. And that's a great segue into the next question here, which is, when we look at the light that we do get from that LED screen, and then you're mentioning, having a lighting package and having your grips there, what are the advantages you get from the LED screen? What are some things you can do with that you can't do as well with traditional lighting? And then what are the things that you do need that traditional lighting for?
I think what's tremendous about having the video panels there is that you've got a natural element for a few things. One is the talent that's in the volume actually has something to interact with and look at. If there's a car driving by, if there's a spaceship invading the planet, whatever that is, an explosion, whatever that is, there's something interactive, and that's something that's very difficult when people are kind of in a void, needing to know what to do, especially some of the earlier virtual production that I had personally worked on, where we used it with there was a child actor, and we were able to get scenes shot very rapidly without the kid needing to go over and over and over with green screen around them, because didn't know what environment he was in. So that was very effective. And it also is fantastic for that, driving down the Vegas Strip at night with neon and all the colors and things passing by. That it's a lot easier to handle those things in video than programming thousands of lights to be synchronized and do those things. But as soon as now you take that same driving shot and you want to do something during the day, and there's the sunlight coming through the trees and you've got those rays of sun, you can't achieve that with a video wall. You have to have practical lighting with very narrow beam angle and the correct colorimetry in order to achieve that correct look.
A theme that came up when we were preparing for this in our previous discussions was encouraging filmmakers to see LED volumes as a tool for making awesome films rather than as some magic solution to all of your lighting and background problems. So I would love to hear some stories of how you've seen this play out for good and bad on projects. When have people really gotten that and made awesome things, and when have you seen people make those mistakes?
I think the most obvious examples would be the shows that started employing this technique in a positive sense, that made it popular, which is shows like all the Star Wars shows from Disney, and then a lot of the recent Star Trek shows. You've got very VFX heavy, expensive looking shows, where people are going to different worlds and different locales and whatnot, and it works. It works in very tight production schedules because instead of flying everybody and doing very long stage builds, now you had virtual environments played out on massive video screens that could be changed on the fly. This is the positive aspect. The negative aspect of it is because there are new technologies that were new to filmmakers, LED walls. The concept of the LED wall, it's really just a big TV, but it's a big TV that's more complicated because now it's not just a single box. Now you've got a lot more new components that people are still learning.
So we were doing a car process shot. So we had the plate in the background, but the car had a lot of complex curves on it. And it turned out the extent of the volume we had wasn't big enough to provide images over the entire car, because cars have windshields and hoods and all of this. So we did the first shot, and people were going, the reflections, we aren't getting a full extent of the car. And then you have this discontinuity which drew attention to itself. So we turned off the top panel completely and just went with a black ceiling. There were no reflections then on the windshield relative to the content up high. But what happened was you didn't miss them. They weren't distracting. It wasn't a problem. We lit the talent properly. the background images were there, so we're still getting bouncing off the hood, so it looked like the car was moving. Shot worked great. The point was, we didn't have to reproduce 100% exactly what happened in the real environment. We had to create something in the camera that was believable. And by leaving out that unnecessary detail, it actually became more believable. And so we used the technology of virtual production in both of these cases to take out the elements that weren't believable and to make the image feel contiguous. And some would argue that we made compromises, but that's the nature of making the shot successful.
And that's filmmaking. That's every single, but it just makes all these challenges filmmaking easier if everything's working. And that's the big gotcha, is everything working?
So in our other panel that I mentioned at the beginning, where we had a whole panel about color management on LED volumes, in talking with those guys, they mentioned that, Tim, you kind of have a whole thing about white balance and LED panels that you like to get into. I don't want to go all the way there because that's a little bit getting into color, but I think it's worth acknowledging in terms of when we're using these LED panels to help light our environment.
Sure. Yeah. Well, as I mentioned, it's not just using the LED panels to light an environment. You've got normal fixtures as well, and you've got a camera, and you've got people, and you've got basically a very large TV screen, right? And how do you keep straight of everything? Well, that's the cinematographer's job. Cinematographer's job is to make sure that the world the camera sees is consistent, right? Otherwise, you break that uncanny valley, that the magical trick illusion. So the real challenge that I've found personally, first of all, is that any camera that shoots a typical LED tile that I've seen on set will never see it as the white that it's calibrated to. It always deviates. It always deviates. There are many technical issues due to that. So what do? If you white balance, what we call white balance, the camera, adjust that perception problem that the camera has to the wall, but then that means that corrective white balance now needs to be compensated for with all the lighting. And that becomes a big complicated problem because then your lighting technicians have to adjust every single light according to that shift, right? The other way that you can go is to balance the wall to the camera, because now you're getting the wall in the right space that everything else is already being seen. So that really is the way to go, but that's a challenging thing too, because white balancing content in the wall is a hornet's nest, and it is the right way to do it. But there are many ways to do it. There's all sorts of approaches to do it, and I'm not going to get into those weeds. But ultimately, that is a challenge that the industry is facing, but is addressing and trying to address.
Related exactly to what Tim was mentioning, this is some technology that we've been working on at Megapixel in the lab as reference design, and some of these images will be in the VES chapter that Susan was working on. These are two identical RGB panels, but the panel on the left, we've added a white component to that's a D65 phosphor, and any camera that you point at the display, white looks white. It doesn't look pink, it doesn't look green. And so I think this type of technology, as it gets into the panels, will help alleviate a lot of the problems that we have today, mixing the broad spectrum lighting and the narrow band RGB LED panels.
For years, when LED lighting first came out, people objected to the quality, that just simple RGB LED didn't make the kind of quality and illuminating talent that you would want. And so for years, everyone working in LED lighting has been working on, how do I make a white spectrum, a white light source that makes human flesh tones look attractive? Because 70% of our content is talking heads. That's what it's all about. It's all about the emotional connection with the face on the screen. No one believes that an RGB light source like an LED wall panel is a good light source for flesh tone. I think we would all agree that as just purely as a lighting tool, virtually no DP would pick it in a shoot off as a lighting source. They would always pick a fuller spectrum tool, something that's closer to what everybody loves is a Fresnel tungsten. Beautiful full spectrum, that feeling of glass, that kind of thing. And the challenge is that LED walls inherently, even though they're fantastic at rendering environments is a very poor light source for human flesh tones and for faces.
Yeah, and I would say just a lot of stuff besides human faces. So,
Yes, that's valid.
Commercial, shoots that need, or anything where you have a product or wardrobe or anything, especially with the color orange, will turn red. The object will turn red to the same hue of red objects. And good luck trying to fix that in post, because sometimes you get that crossover of values that just becomes very untenable to fix.
A lot of this has to do with the fact that, a lot of things that you illuminate, whether it's a person or let's say a car, there are multiple levels and there's translucency to objects. Our skin is not an opaque object. Clothing absorbs light in different ways and reflects different wavelengths back out. But chrome, for example, is a very tough surface opaque thing. And that's why like highlighting chrome edges for driving plates works exceptionally well. But things like flesh is not, fantastic to illuminate with RGB, especially from the standpoint that LEDs were created in the first place to be very energy efficient. And so the way to drive that efficiency is to turn the electricity that you're consuming into like the peakiest, narrowest wavelength possible, so that it's generating like a high peak amount of light, but not necessarily quality. And so now that the illumination devices have such high quality, we'll see that become more pervasive in all of the technologies.
Yeah, so let's bring this back to some ideas for some things that people can take with them and use on their own productions. One of the things I love that you've brought up, I think all of you have brought up in different ways, is this idea that this is just a tool for making films, the same as all the other tools we've been using for forever, right? For paintings behind the set to green screen, blue screen, all of that.
Yeah, well, I think a lot of things come down to, what are you trying to achieve with it, right? And when we take, for example, worked on a film a long time ago that was using, let's say, very heavy, as you would say today, image-based lighting for Curious Case of Benjamin Button. And it was all driving plates. There was no such thing as a game engine back then, but all the plates for this large train car were beautiful dappled sunlight coming through the trees. And so it was a train car going down the street, or trolley car rather. And when we first started playing the footage back, you saw all of this green light hitting all of the people's faces and elbows hanging out the window. Trim on the trolley car, because that's what was in the plate. It was trees. And that was sort of an aha moment where we said, wait a minute, we don't want any of this green light. Like the trees, even though they're emitting an image in the video file, should actually have no image playing back on the lighting, and that should actually be like video black, if you will. And then we want to turn on all of the background, which is the sunlight, dappling through. And so overnight, I actually wrote a GPU shader that was a live keyer, so that we could key out, the trees and just have like dappled sunlight coming through, and it was an amazing effect. And I think Chuck was talking an earlier time where we were speaking, where a great example of like the headlight of a car that was in the background plate. Chuck, you may want to talk more about this, but if you take a picture of a car driving at night and you're looking at the headlight of the car, that image of the headlight is not going to project light into the scene like you think it will. People think, oh, I'm going into a volume, this is going to create the correct lighting. Really what you want to do is like poke a hole in the LED volume or in the LED wall, like shine a bright, narrow band flashlight through the thing so that it creates a beam. And these are the kind of things that a lot of people don't always make that distinction, is that the LED volume is not the lighting. It is the environment that people are in. It is the background plate. It's the green screen replacement technology of today, but it's not specifically giving you all of those elements that you would have in the real world.
But to add to Jeremy's point, and what I think makes it really interesting is, you can deliberately place lighting sources, motivation for lighting in the background to deliberately draw the foreground into the scene. So we were doing a cafe scene, for example, and we wanted to make it look like the actors were sitting in this cafe scene at night. So we put a fluorescent, a neon sign above them that was flashing red. Now, what that let us do is it let us take an off-camera light on stage and flash red on the talent. And so what you immediately got was a connection of the background image in Frustum with the talent in the foreground sitting at the table, the red light causing them to flash red. You can actually create the illusion of drawing drawing the talent into the scene by creating a motivation for off-camera lighting that you then reproduce in virtual production using a hard light. And the challenge Jeremy talked to is the one thing LEDs well don't do is project lights with constrained beam angles. A headlight's a great example. There's a headlight in the background. You don't get a beam of light off an LED wall. Sunlight is the most difficult. Sunlight has a 0.5 degree beam angle. There isn't an instrument available on set that can reproduce true sunlight. You can get close, you can try to mimic it, but you can't hit that level of power and that narrow beam angle yet.
I would disagree highly with that, because any fixture, including your reflex units, right, could absolutely do that.
Can give the illusion, but it can't do 0.5 degrees.
They absolutely can, because and I'm not saying this to be contentious. I think that I don't realize this about your fixture, maybe, is when you're in full spot, you just have to multiply the distance of the face of your light by 107, right? So if it's a 1 foot size, right, then if you put that 107 feet away, or use a mirror and put it 50 feet away and whatever, or 25 and have two mirrors, whatever, you could absolutely get that in a smaller setting.
In a very small location. The challenge is if your entire set has to have the same 0.5 degree beam angle, a 15 degree spot can only illuminate a portion. Then you end up with multiple sources and you end up with different shadow angles. But I agree with you. You can create an illusion.
Yeah.
You can create an illusion that's similar, but you can't light the whole environment with the equivalent of sunlight on set.
Sure. Yeah, but that's what filmmakers have been doing for 100 years. That, and this is where I'm saying
exactly. And you create if the illusion's good enough, you can cross uncanny valley. People don't care, but it is a challenge, especially in virtual production sets where people most of the content's being written to avoid direct sunlight on the big series because it's such a challenge.
Yeah, and I think that though we are at a point in history now that this is changing. Because I've already been, in my former position, I created lighting volumes with fixtures that could play out video environments, an HDRI plate, for example, or a moving plate, a classical VFX technique of image-based lighting being played out on fixtures where you are getting hard light, you are getting sunset environments, so that when you do what, as an example, a scene like the train scene that Jeremy mentioned, when you get the relative differences between the world of the trees versus the hard light coming through, you can now get that light difference from the fixture versus the tree, so they're not overly green. They are much darker value, and now you're getting the hard sunlight as the real key. And I think that's the frontier and where things are going to be going next 2 years is the standards of lighting communication and calibration and whatnot are getting there already. Then people are going to be doing this a lot more often and not as expensive as people would think. And I think that's the big thing here.
That's a huge attribute, and I think that's what people underestimate. Our volume is only a little over 30 feet wide.
Yeah,
and we could do a ton on it. It works great, and it didn't cost $30 million, and it doesn't use a 50,000 square foot facility, which I think is unfortunate that some of the most successful projects have used such large volumes. They're setting the bar too high, and people are saying, but can I make it economical and use it in smaller productions? And I think Tim and Jeremy, you've probably both had the experience. Yeah, you can. If you scale it appropriate, it can be an economical solution.
And I think the mistake that a lot of these build-outs and stages that are building virtual production stages, they are putting too much pressure or heavy lifting on the wall, the rear projection aspect, and not on the lighting aspect that we were talking about here. If you start getting fixtures that can play out video or are compatible with video, you don't have to have a dense field, a perfect field that can do video. You could have more sparsely populated fields of light with fixtures that could do hard light or that could do soft light or whatever. That could play out these environments, and it could cost a fraction of what they realized. And I think that, and get better results. And I think that's the idea here that that I would like to promote, is that we are trying as filmmakers just to do these things that were promised a couple of years ago with these large build outs. And it's going to be doable very soon. Or if not already, I think it's already doable now. It's just, you just have to realize it's doable.
Yeah, I think if you look online, Star Trek Strange New Worlds, they're doing fantastic work on consistently using a volume, using same sets, same, like their engineering section and all that. The videos online are great, but that's a case of where I believe they're economically using virtual production to really do very impressive work. I'd love Jeremy to talk about metamerism. I'm a huge fan of that word, and I think it's a word that people need to use more frequently.
Yeah, with metamerism, the notion of having one object that's one particular color, could be a painted car, and it looks different with different lighting environment effects. It looks different with different types of cameras. It looks different to your eye, yet a spectroradiometer might actually meter it as the same color. And so just because something is a specific known value, it is not always perceived as the same color.
The classic example of metamerism is you buy a brown suit and then you walk outside and it looks kind of green, right? Haven't you ever bought that piece of clothing where you're inside the store and it's kind of a brown neutral something, and then you walk out in sunlight and go, I had no idea it had this much blue in it or this much green in it or something. So the same object in a different lighting environment looks a completely different color. That's the implication of metamerism. And that definitely happens on set, right? Where, as Tim was talking about, props, costumes, those kind of things, where depending on what light source is used to light them, they look completely different on camera. And the amount of color shift it's surprising how distinct and significant it can be.
What happens very often with, and I'll take RGB LED as an example. RGB LEDs are put together to be able to make a white point or mixed colors, anything within a CIE color triangle. But what's often not really well understood is that in order to achieve, for example, a very specific color of red, let's say a Rec 2020 red, which is a broadcast standard, if the red LED in that fixture is more saturated, which typically they are much more saturated, then in order to hit that particular point to be measured scientifically, there needs to be a lot of green added to it. So then what happens is that the human eye will see something that's more orangey. A meter will meter just red, and then a camera may or may not see orangey red. It might see oversaturated red. It might see undersaturated red. And then the human brain can also play tricks on you, because your blood sugar actually will have an effect on what colors you see. So you can have something dialed in and say, I really like how this shot looks. And then you can go to lunch and you can eat a big piece of cake for dessert, and you come back and you actually see different colors. And so, if you can't even trust your own eyes, how can you, assemble all these things together? And so that's a big element where the broad spectrum lighting, where it's not just narrowband RGB, but we're adding in a phosphor white, we're adding in 2 phosphor whites, or secondary colors like amber and cyan and magenta. These things are all contributing to sort of, let's say in layman's term, like a more well-rounded type of color that's hitting an object. And this creates a much more natural look like you would have in the real world. And so this really bridges the gap. But when we have all of this amazing technology in the lighting fixtures, and we don't have it in the display that's captured in camera, you have these massively two different let's say, color technologies trying to reproduce the same thing. And you can go around all day long and say, yes, I metered this and it's D65, or I metered this and it's 2700 Kelvin, but they don't look the same at all. And so this is something that the industry is working really, feverishly on to try to correct and do a better job of, but it's going to take some time. And Tim can probably go on and on about this too.
I think the very important thing to consider about all this is the bigger picture questions here, right? And the bigger question is, what is the thing that is most important? And in my opinion, it's the camera, right? The camera is the thing that is seeing everything and is capturing everything and then recreating everything in post, right? So that's when we're talking about even the word metering, the tool you use to quote unquote meter is a rudimentary form of a camera as well. And a lot of the problems we're talking about here is that the meters, the cameras, the quote unquote cameras that are these meters are not the same as the capture camera that we're using on set. So that's already a point of discontinuity there. So what the real arbiter, again, of this is you have to understand the arbiter, you have to understand the judge. In that case, you have to understand the camera. And in order to understand the camera, you have to understand that every camera has to go some sort of form of technical process called calibration. When we're talking about the word calibration, it just means that if I have a standardized spectrum of light hitting a standardized set of colored objects, do I get that color, or what do I do to that data that the camera gets to get that color to line up in my video standard after the fact? So that process of conforming all the captured information is set in stone by a standard calibration process, and that's where things break. When you have a light like these narrow, spectral tiles interacting with the world, that is not the same spectrum that these cameras are calibrated to, and therefore that's where you start seeing all these discontinuities happen. For all these different reasons. Yeah.
Now, to shift a little, because I'd love to hear Tim and Jeremy's thought on this too. The successful shots we've seen in our experience is when the director and the writer understand the limitations and the capabilities of virtual production. And frequently what we're engaging is a previs step, where they'll actually construct in Unreal Engine or a similar tool a mock-up of what the scene's going to be like, including lighting. And so you can actually design the Outer Frustum lighting in previs and view how this is going to work, and then use it not only to potentially create your content on the wall, but also to see, is this something that's achievable? Is this shot going to work? Is it going to be believable? And in our experience, the productions that are more experienced and do more pre-planning seem to have much better success than the productions. And this is one of the challenges as a workflow is virtual production is not is much more challenging if you do kind of a shoot from the hip. Let's see what happens in the camera on the day of without the pre-work. And I don't know, Tim and Jeremy, is that consistent with your experience as well?
I would say, yeah, absolutely. I'll give you a couple examples. You had mentioned Mandalorian and also Star Trek. I think those are fantastic examples where, the game engine assets need to be done perfectly, and it's really an entire world that's done ahead of time. And the previs and the live shooting and the post is all kind of one big process with the same teams all talking to each other. And they're able to leverage all of these assets, across an entire season. And it works very, very well and is quite convincing. And I think car process is another absolutely fantastic use case where it's an isolated thing and you're saving tons of cost and time, not having to tow cars, down the street and close the street off, and you only get a few takes, that sort of thing. But you're right, Chuck, in that, it requires a lot of this planning. So if a TV series or a movie is done in a very much like a storyboarded way where the DP and the director and VFX are all involved in storyboarding everything out and having the shots locked in and understanding, where things are, that's highly, highly effective. But if you get somebody in that's sort of shoot from the hip, I was talking to a friend of mine that does VFX, and he had an LED wall set up. It was not large. It was 25, 30 feet, and it was a really nice kind of contained shot, not a massive volume. Everything was looking really good. But then the director and the DP decided to like do all these crazy camera angles, and they were capturing the talent fine, but they ended up shooting like off the LED wall, and there was ropes and rigging equipment in the background, and the production ended up needing to rotoscope out everything, even though the shots as they had been planned would have been perfect. They went way over budget in post-production because they didn't follow what the plan was, and so clearly they hadn't really thought that through.
The company we were working with wanted to do a virtual production test reel, and so they decided to do a storm and have lightning. And the key there was really precise timing of the lightning strikes. And they actually got that dialed. So they were able to put several of our largest hard lights off stage, or Outer Frustum. And then as they played the background plate, every time a lightning strike hit, it just blew out the stage. We had fantastic bright light hitting this. And it was very convincing, right? It made it look like the talent was in that environment because we had this very, very synchronized lighting event in the background that was reproduced in the stage in the foreground, and it worked really well. And I think those kind of events where you can use lighting to draw people into the environment is very effective.
So, there are three practical approaches, when you're using basically the world to light, because that's what we're talking about here, right? Is we're using the virtual world that we have, whether it's a video plate or a whole full gaming engine generated world. There are three ways that you can play it out as your light source on set. You can either do the ideal method, where, quote unquote ideal, where you completely surround your talent and stage with video screen and fixtures completely, so that when you play a video onto it, you can virtually light and create lighting fixtures just by painting it, if like in a Photoshop type style interface, and move, let's say, a white card around, a light card around, whatever. This is where what the big shows are doing, right? They have, whether it's Unreal, whatever media server, Disguise, or Simulate Live Effects, you can virtually move a card around with any color that you want, or a video plate, and that becomes your light source, right? This is not tenable for most people. So what I would say is tenable will be either one or two other options, which would be the second option, which is you've got what I call the windows to the world approach, which is what I think Chuck brought it up earlier, is that we selectively light anyway. If you want to turn off the overheads, you turn off the overheads, but you just have selective, how am I actually lighting my world? And then you put the lighting fixture arrays or video screens in the right place that the camera sees. And ultimately, now you've got, and then you can tweak them with video content, the world that you have, etc. And then the third option would be a full DIY. It's now you're breaking it apart. It's not just windows. Now you've got, things at different distances, fixtures, really a mix of different types of tools to play out video-based lighting on the set. Tiles for direct reflections, or fixtures to do hard light. Just like Chuck was mentioning, this is what I would call the DIY approach, where you've got fixtures all around in the right place, timed perfectly to the content and being driven by the content. So that's the big picture, I think, that needs to be understood moving forward. If we're talking about virtual production and how this, quote unquote, is distinct from traditional production techniques, that this is where things could go. So I wanted to at least present this, because this might spark some, I think, on-set, anecdotes from Chuck or Jeremy.
Yeah, I think this is a really good point, that not everything needs to be a gigantic volume. I think Chuck's analogy of the car process before with the ceiling was actually a perfect one, right? In which the volume was not nearly large enough with a large enough ceiling to properly have reflections on the windshield and all over the place, because it didn't kind of extend into this infinity beyond the car to give that sense of realism, even though there was interactive lighting that was illuminating people and some of the hood and other things. And so turning off the ceiling didn't provide that added element of reflection. but the fact that it wasn't needed to pull off the look, I think is exactly that point that we're all making in terms of like, this is all movie magic, right? We're all, trying to simulate these environments and just help creatives tell a story. And if you don't necessarily need that special extra whiz bang thing to tell the story and people are immersed in the environment, you've done a good enough job. You don't need all the other stuff.
Yeah, a good example was Murder on the Orient Express, the recent remake of that film. That train car was done with virtual production. And what they did is they lined the windows of the train car with LED screens. And so when you watch that film, all the reflections, and they deliberately have a lot of scenes where people are eating and there's crystal and there's silverware. And there's a lot of things that if you'd done it with green screen, just you wouldn't have been able to sell it. Or the amount of burden in post to add the reflections would have been onerous. And so instead they lined the site and then they took plate shots and they were able to play that. Now, as Tim's mentioned before, when you're trying to reproduce sunlight, you've got to also reproduce the magnitude of which sunlight is brighter than the inside of a train car, for example. So most of the time, the effect is the windows are almost blown out. You see stuff moving by, but because it's sunlight, it comes across as much, much brighter than the ambient light in the train car. And that film, it really works. They did an exceptional job, that team did on that film. But that's a great example where it didn't have to be a 360 volume. There's no reason to have LED panels over the top of the train car. You had to have it down the two sides, and they used it very effectively.
And the one plug I will say, and in that particular film related to the technology, is that was the first in-camera virtual production that I'm aware of, and those were my panels and processing and things. But that was dual 8K even back then, and so it also kind of paints a picture to how difficult it is on the technology side for all of these pixels to be managed. That these rasters are getting bigger and bigger and bigger for the volumes when it started out that high resolution, and so that's what I think all of us as technology companies are trying to make all of this as easy as possible to use, even though it's like the most bleeding edge technology you could possibly be putting into these environments.
So this is a question for all three of you that I think could be really helpful for our viewers when they're actually getting on set and they're going to start working on these productions. So as the person responsible for the lighting, is there anything during that pre-production or even before that in just the planning process that you should be aware of to avoid or to not get yourself in trouble? Right. Again, thinking maybe on a slightly lower budget production, right, where you can't just throw money at the problem. What are some examples of just things that people should be aware of that maybe aren't impossible, but might be difficult or might pose some problems?
The problem that I've seen a lot is that DPs have this notion, oh, yeah, we just light with the wall, right? Well, that's not really tenable. We have to understand that. You can't just assume that, number one. But what we can assume is if you do light for the wall, that the wall is a fixed commodity of exposure. Now, you can adjust up and down, but ultimately, 18 nits, if you map a gray card to 18 nits, 18 nits is 18 nits. That's a fixed exposure value. Or if I, let's say, map it to 72 nits, my gray card of my scene is always going to be at 72 nits, I can know that ahead of time and adjust the world around that, right? So then, therefore, I have a fixed lighting exposure level that I could tell my gaffer, oh, if I'm living at that level, then we're shooting at ISO, 200 at a 2.8, right? Then the lighting team can always assume that. And then I am not doing what the problem that I've seen happen a lot on productions, something called the exposure dance, where they start creeping up, creeping down, creeping up, and start creeping up, and realizing, oh, if I need less light, but then you start living in the toe of the volume, then you're dealing with bit depth issues now. You're seeing flicker, you're seeing banding, you're seeing all sorts of problems that you don't want to see in your background. But if you go the opposite direction, and you go on the brighter end of what the walls can put out, all of a sudden, now you're going to need a 20K to be your sun versus an M18, which is, a lot less of an output. An 18,000 watt 18K HMI versus a 1.8 sorry, let me rephrase that again. You're going to start needing an 18K or 18,000 watt light versus a 1,800 watt HMI to be your sunlight. And these are the levels of differences that you might need if you start pushing the content brighter and start NDing your camera down, because you want it to feel like sunlight, let's say. And I've seen this happen, and the gaffer was not prepared because the DP told him, we're going to be living at ISO 3200 the entire show. So these are real issues that need to be nipped from the bud ahead at the very start. And I think
I completely agree. I think there's a major workflow challenge. So normally on traditional sets, you do the set construction. So after you finish set construction, the lighting designer who usually has the plans for the stage beforehand, then they'll be given a couple of weeks to pre-light. And so they'll rig all the lights, and then they have a couple of weeks to debug their pre-light. They have a board op there, and they do it. The challenge with the virtual production stage is a plan of that stage doesn't tell you at all what you're lighting for. It just tells you where the wall is going to be located. The challenge you've got is, and we've seen this happen, a production will come in and say, here's my plate footage. And the lighting designer's like, I don't know what's on that plate footage, so I don't know what's on the wall, so I don't know what lighting I'm trying to reproduce. And so the fixture selection, where you place the fixtures, is not a function of how the LED stage is built. It's a function of the content on the wall. And so a lighting designer who's trying to light for virtual production has to say, I need to have all the details, not only of the LED stage, but I have to have all the details of the shot. What does the plate look? What does the plate look like?
Yep.
If you have a 3D model of an Unreal Engine, I need the content that I have to light for, and that's really seriously underestimated a lot of times, and it makes it an impossible situation for the lighting designer, because they're saying, well, just light for the LED environment, and they're like, that's not what I'm lighting for, right? I'm lighting for a street scene or an airport scene or a outdoor pavilion scene, and without knowing that in advance, it's extremely difficult to do a decent lighting plot and to prepare.
I think that this might fall on deaf ears in the audience, but I hope that it won't. Which is that we need to be able to establish a clear lexicon of the exposure of the wall and say, I'm living at 72 nits for my nit values for my gray card, right? The middle gray card of my scene needs to live at a certain value, and I have to stick to it as much as I can, not like a robot, but just to help everybody figure out how we're going to do all this, right? And once we can set that, because that is something you can define in Unreal, but I know things go up and down all the time, but at least you have that line in the sand to start with and move around. If you have that as your reference point, you just have to know that's a reference point and that there's lexicon involved, and that's called a nit level, which is the brightness level on the spot meter on the screen. So if I throw up a gray card of that scene that's lit and whatever, and it lives at 72 nits, there's an exposure value there, and that exposure value would be ISO 100 at a T3.2 at 24 frames per second, right? Then, again, all the lighting designers will know, well, if I'm in the stone, I'm going to choose the right types of fixtures, and also know as a wall technician, or the person doing the color management, that I now have 4 stops of headroom overhead that's getting clipped out, or 2 or 3, whatnot. These are the sorts of things that it just kind of clicks into place as long as we start from that initial point of exposure. And I think that's something that's a good practice to start with. As a cinematographer, it starts with everything. And I think that's a really important thing to establish.
So one of the things that, to take into account is, essentially a camera is taking images at 24 frames per second, right? So that's capture and then wait a moment in time, capture and wait a moment in time. The LED wall is also kind of doing the same thing, right? The LEDs are illuminating with what's called pulse width modulation. And so the LEDs are actually blinking on and off so that there's a perceived luminance level, but LEDs in a display don't actually dim like a traditional dimmer. Each pixel is actually always pulsing on and off at the same luminance level. They're just pulsing on more often or off less often, to raise these levels. And so when the luminance of the display goes way down, meaning you've gone into like the shadows of a dark scene, basically the LEDs are blinking on maybe very sparsely, and the rest of the time they're off. And so what happens is you can get into these beat frequencies where certain LEDs around the display happen to be on, some happen to be off while the camera is taking its exposure. And especially for a rolling shutter, where the lines are actually progressively being recorded on a camera sensor, they can record sort of this random interval of LEDs might be on, they might be off, and that's where you can get banding and different kinds of artifacts. It's very typical in super, super dark scenes to have what looks like mostly a uniform exposure, but then maybe like a quarter of the frame looks dimmer than the rest of the frame, or it looks brighter than the rest of the frame. And that's where the camera sensor happens to catch the LEDs getting that one extra pulse on for that portion of the frame. And there are a lot of mitigation techniques that we have, like, for example, in our processing, to work around these issues and kind of allow some of these complex shooting techniques to happen while also keeping the LED wall performing well. But they're not automatic because every single camera operates differently. Every crop sensor mode versus full sensor, project time bases, these all factor in. And so until the cameras are talking to the LED processors, in an automated way, which is on the horizon, but it's not there now, you can run into these issues. You do need to make sure that there's an expert on hand to be able to figure these things out kind of in the live environment.
So we're nearly at the end of our webinar, and I would love to get some final thoughts from each of you. What would be the most important lesson that you have learned working on an LED volume? Could you just summarize that for us as something that our listeners can take home and use? And Tim, we'll start with you.
Sure. Well, I would say if you're doing virtual production, is to think about what you're doing, right? What you're really doing, again, is when you're creating a virtual world or whatever virtual elements you're trying to bring in, you still got to see it. And the technology that exists to see it by camera has been around for 100 years as a concept, which is rear projection. So as long as you can understand that as a distinct thing, then if you start realizing that how you do a virtual production is the same thing as how you do any typical production. None of these concepts have changed. So how you light for your scenes, what has only changed is the ability to light with video-based environments, whether it's through fixtures or whether through TV screens. The ability to do that has grown exponentially in terms of ability. And that's something that you can bring to the table that's new. But if you can't, you can still light it traditionally. And that's something that I cannot stress enough. And that your lighting technicians and your DP need to understand that as well, because sometimes it can be really scary. All this new technology, all this new tools. But ultimately, at the core, we're still doing the same thing. We just have a couple of new tricks to work with.
Awesome. Jeremy, you want to go next?
Sure. My recommendation is always to think about the look that you're going for. And so also, if you're kind of tiptoeing into this, recognize where it's helpful to use technology to help you with storytelling. And then, kind of it's okay to lean away from it if it's something that's not important to help enable your story, and to think through also where virtual production is extremely beneficial and helpful and looks good versus where it's a little bit more challenging. So we've talked a lot about the notion of hard light versus soft light. If this is your first time using this kind of technology, maybe lean towards something that's a cloudy day with more diffusion rather than something that needs, hard, harsh sunlight shining on people or objects, because that'll help you ease into it and kind of blend in the technology a little bit more.
Awesome. And Chuck, how about you?
My advice would be for people just entering this is take the layup. Look at your story, plan the scene, and go for a scene you're confident you can achieve with the equipment, the budget, and the people you have. And that'll be satisfying. If it enables your story and you get where you need to go, I think the biggest challenge people have is they do something too ambitious. They're trying to do a scene that they can't think of another technology that they could possibly achieve. And then they get frustrated when they don't get something that looks, again, crosses uncanny valley, where it looks so real that it adds to the story. And so I'd say, especially for people just getting into this technology, do it in a way you know you could be successful, where you reduce risk and plan it well, and then it can be a very successful technology.
Well, thank you all so much. That is all the time we have for today. First, I would like to thank our panelists for sharing your experiences. And also, I would like to thank all of you who listened to this panel. You are the future of virtual production, and we can't wait to see what you create. Thank you all, and thank you to our panelists.
Thank you.
Thanks so
Appreciate
much.
it.
Thanks for having me.